Binary operations, commutative property. Given a known empty set S, which is closed under a binary operation star, if for all A and B members of set S, A star B is equal to B star E, then the binary operation is said to be commutative. Given a known empty set S, which is closed under a binary operation star, if for all E and B members of set S, A star B is equal to B star E, then the binary operation is said to be commutative. Therefore, a binary operation star is commutative if the order of combination of any two elements of a set upon which star is defined is immaterial. That is, if it's not important, meaning that if the order is not important, then the binary operation is commutative. Examples: if PQ, members of the set R, where R is a set of real numbers, then P plus Q is equal to Q plus P. And if P times Q is equal to Q times P, then it means addition and multiplication of real numbers are commutative. So logically, X plus Y definitely gives us Y plus X. What it means is that under addition, when you're combining two elements under the operation addition, you discover that the order doesn't matter. If you order means which of the elements of variables you start off with, or you decide to start first with. So I could decide to start with X. In this case, on the right hand side, I started with Y plus X, but on the left hand side, I started with X. So it doesn't really matter which elements you started with, you are still going to get the same answer. So let's take real numbers. If X represents 2 and Y represents 3, so if, in this case 2 came first, so we started with 2 first. So let's reverse it. 3 plus 2. 2 plus 3 is what? 5. 3 plus 2 is what? Also 5. So whether you start with the first one or you started with the second, order is not important. So if order is not important, if you decide to start with the first element and then the second element, and then you combine them under the operation addition, or you decide to start with the second element first and then followed by the first element, and then you combine them under the operation addition, if they give you the same answer, then that operation is commutative. So X plus Y, if it's equal to Y plus X, then addition is commutative and it's general. Addition is generally commutative. Addition is commutative. So you can choose 13 plus 9 and then 9 plus 13. So it doesn't matter which comes first, whether the first or the second order is not important. You're still going to get an answer. 13 plus 9 is 22, and 9 plus 13 is also 22. So you got the same answer. And let's look at multiplication. PQ. With PQ, if you change the order now, in this case, P comes first before Q. So if we change the order, are we still going to get the same answer when Q comes first? Let's find that. 3 times 2 is the same thing as 2 times 3. Let's see, 3 times 2 is 6. 2 times 2 is going to give us 6. Yes, we got the same answer. So what does this tell us? It tells us that multiplication itself is also commutative. So multiplication is also commutative. Multiplication is commutative. So whether you started with the first element or you started with the second element and then you combine them together under the operation multiplication, the answer will still be the same. So if it is the same, that implies that multiplication is commutative. So that's what this first example means. So from what we've gotten, we can say addition and multiplication of real numbers are commutative. Now let's look at number 2. If PQ members of R, where R is a set of real numbers, then P minus Q is not equal to Q minus P unless P is equal to Q. Let's find that. So we can see P minus Q. So P minus Q will it equal to Q minus P. Let's find that. So on this side of the equation, P came first, and on this side Q came first. So let's see if we change the order, whether it doesn't really matter or if it matters. So let's try 3 and 2. Okay, so 3 minus 2, and then here, so P is 3, Q is 2. So Q, 2 minus 2. Are they going to be the same? 3 minus 2 is 1. 2 minus 2 is equal to minus 1. Are they equal? No. So this implies that P minus Q is not equal to Q minus P. So if we change the order, subtraction, and they combine the two elements under the operation subtraction, we're not going to get the same answer. So what does that imply? It implies that subtraction is not commutative. Subtraction is not commutative. That's a simple conclusion. So let's go with the only time subtraction can become commutative is if this condition is met, unless P is equal to Q. So if P is equal to Q, and that, which in most cases is not. So assuming P is also, Q is also 3, and 3 minus 3 is 0. And so if P is equal to Q, let's say if P is equal to Q, so let's say 3 minus 3 is equal to 3 minus 3, because P is 3, so Q is also 3, 0 equal to 0. So that is when subtraction can be commutative, but you know that condition is not cannot always be met. So generally subtraction is not commutative. So division, if P divided by Q, will it be the same as Q divided by P? Okay. I'm going to assume that P is 4 and Q is 2, and then Q 2 and then 4. So here 4 over 2 divided by 2 is equal to 2. 2 divided by 4 is 1 over 2. They are not the same. The only time this can be the same is if P is also equal to Q. But if P is equal to Q, so let's say 4, 4, 4, 4. So this is equal to 1. This is equal to 1. So this is the only time that the order, if you changing the order, is not really important, because it's still going to be the same answer. That's if this condition is met. But if this condition is not met, generally, from what we have seen here, division is also not commutative. Division is not commutative. So if PQ members of R, where R is the set of real numbers, then P minus Q is not equal to Q minus P unless P is equal to Q. Similarly, P over Q is not equal to Q over P unless P is equal to Q. Hence, subtraction and division of real numbers are not commutative. An operation star is defined on the set of real numbers R by E star B. E star B. E plus B plus 3EB plus 3EB. For all A and B members of set R, is operation star commutative? Well, if the operation star must be commutative, means that A star B for the operation star to be commutative. The commutative means A star B must be equal to B star A. So already A star B is already defined. Now let's get B star A. So B star A, so what it means that from A star B, so now B comes first and followed by A. In this equation, wherever A was, we're going to replace A by B, and where B was, or where B is right now, we're going to replace it by A. So because we have changed the order, so it also reflects on this definition of this binary operation. So now it's going to be B plus A plus 3BA. Now B plus A is the same thing as A plus B from what we know about commutativity under the operation addition and multiplication. So since B plus A is equal to A plus B and 3AB is equal to 3BA, therefore B star A is equal to A star B equal to A star B, because B star A, we can also write B star A is equal to B plus A. We can also change to say A plus B plus 3B is still the same thing. So we say hence the operation star is commutative. An operation O is defined on the set R of real numbers by X O minus equals to X minus Y plus XY for all X and Y members of R. Is operation O commutative? Merely looking at it, you can see that this operation has two parts. You have the subtraction and multiplication. So it's just for you to deduce whether it's commutative or not. You know that this part is not commutative, but this part is commutative. So because this part is not commutative, generally this equation or this final operation O is not commutative. But let's find that. So X O Y is X minus Y plus XY. But so what if we change the order? Y X. Let's see. X. So this will give us Y minus X plus Y X. Now, since for subtraction, X minus Y, is it the same thing as Y minus X? No. So since Y minus X, from what we have here, Y here is X here is positive and X here is negative. Y here is positive, Y is negative. So they are not the same. Therefore, since X operation Y is not equal to Y operation X, it follows that the operation is not commutative. It's not commutative. Number 2. A binary operation star is defined on the set R of real numbers by X star Y. X star Y equals to X plus Y plus 3 XY. Now we have to find out if the operation star is commutative. For it to be commutative, if we change the order, we're still going to get the same result. Since we already got in this first instance, X comes first. So let's see what the result will be when we start with Y instead of X. So Y star X will give us Y plus X. We just change the order here. plus 3. So instead of x coming first, y will come first. Now what you notice is that this one is addition and this is multiplication. So you know that generally addition is commutative, multiplication is also commutative, and that test is this: x is positive, x is positive, y is positive, y is positive, so they are the same. Now 3xy and 3yx will give you the same result. So with this we can say since x star y is equal to y star x, it follows that the equation star is commutative. The operation star on the set R of real numbers is defined by P star Q. P star Q is equal to Q is equal to Q is equal to minus 3PQ. So we have to determine if the operation star is commutative. For it to be commutative, P star Q should be equal to Q star P. So we have P star Q already. Let's see if Q star P will be equal to P star Q. So for Q star P, our Q will come first. That would be Q is power 3 plus P is power 3 minus 3QP. So is it the same? So Q star, this part is addition, which is commutative. This part is multiplication, which is commutative. Generally, you can say Q star P is equal to, if you arrange it, P is power 3 plus Q is power 3 minus 3QP. So this is a follow the alphabetical orders. In alphabetical orders, P comes before Q. So okay, so PQ. And what do you have? You have P star Q is equal to P star Q. So since P star Q is equal to Q star P, it follows that the operation star is commutative. Number 2, the operation O plus on the set x equal to PQ, where P and Q are members of R, is defined by N is equal to N plus E, N plus B. So is the operation, so that N, E, and B are members of set R. So is the operation O plus commutative in X. Okay, so our rule here is that N plus E and N plus B. So that's what it implies. So which means if we change the order, our order would not be, since N plus E with these two, N plus E plus N plus E. So if we change it E plus N, that would give us, that was which affect the order here, E plus N. But would that change give us the same result? Let's find that. N plus E, let's put it this way. Okay, so N, so this is the first one. So I'm going to say N, and let's say E, N, and then comma O plus, and what comes again? B, N. So what would happen to this side? So in the first instance, when N came first, N O plus A will give us N plus A. So now that A is coming first, E plus E plus E and N. So yes, yeah, and there will be A, B, A will come first, and then here N will come later. So A plus N, E plus N, and here will be B plus N, B plus N. So what do we have? When the order changes here, the order also changes here, but from what we have here, N plus A is same thing as A plus N. So since A N plus A is equal to A plus N and N plus B, N plus B is equal to B plus N. So what does that tell us? It follows that the operation O plus is commutative in X. So given that A star B is equal to A star B is equal to 2A plus B, evaluate A 2 star minus 3, A 2 star minus 3. So here A is 2 and B is minus 3, so 2 times 2 plus minus 3. 2 times 2 is 4, plus 1 times minus 2 is minus 3. 4 minus 2 is 1. So B minus 2 is star 2. So 2 minus 3 plus 2. 2 times minus 2 minus 6 plus 2. That goes to minus 4. So question says, is the operation star commutative? Well, when we change the order, we get the same result. So since 2 star minus 2 is not equal to minus 2 star 2, it follows that the operation star is not commutative. It's not commutative. Number 2, determine whether the binary operation star is commutative on the following. A star B is equal to AB minus A minus B squared. So for A star B, so let's expand this first form. A B will give us minus this part here, A minus B, E minus B, that's okay, and put here A minus B, E minus B, let's put E B. So E minus B, E times E squared, E times minus B minus EB, minus B times E minus EB, minus B times B plus B squared. And this will give us EB minus A squared times EB plus B squared. And plus is EB minus times A squared minus E squared. Minus times minus 2AB plus 2EB minus times plus B squared minus B squared. So what do we notice? EB plus 2AB is plus 3EB minus E squared minus B squared. For we to determine if the operation star is commutative, A star B must be equal to B star A. So we simplify A star B. Let's get B star A. B star E. So I'm going to change the order. B E minus B minus E squared. B E minus B minus E. B minus E. That's what b minus 2 is power 2. This means this branch multiplies itself 2 times. So when we expand, we have ba minus b times b squared, b times minus a minus ab, minus a times b plus minus ab, minus a times minus a plus a squared. ba minus b squared minus 2ab plus a squared. Be minus times plus b squared plus minus b squared minus minus 2ab equals plus 2ab minus times plus a squared equals plus minus e squared. So we know that ba is something as ab. So ba plus 2ab equals 3ab minus b squared minus e squared. So if you change the theory A, B, change the order alphabetically, minus a squared to conflict, but even at this is still the same as what we have here. So consider minus a squared minus b squared. If you check, this part here is equal to a star b, which is equal to a star b. So which means b star a is equal to a star b. So therefore b star a is equal to a star b. So this implies that this implies that the operation star is commutative. So that's the first part. Then it says evaluate theory star theory. So let's call this A part. Now let's call this B part. Theory star minus 1 star 2 minus 1 star 2. So theory star minus 1 star 2. So first thing we're going to value this part. So let b equal to let b equal to 3 minus 1 star 2. So let's say minus 1 star 2 is equal to using this formula, or this formula. The simplified formula is this. So let's say 3 times a is minus 1 times b is 2 minus a minus 1 squared minus b, which is 2 squared. Then minus 1 times 2 is minus 2. Minus 1 times 2 is minus 6. Minus 1 raised to the power 2 is 1. Minus 2 raised to the power 2 is 4. So minus is minus 1 is minus 7. Minus 7 minus 4 minus 11. So our b is, therefore b is equal to minus 11. Now therefore 3 star minus 1 star 2 is equal to 3 star b is equal to 3 star minus 11. And 3 star minus 11 is equal to, from our formula, 3 is 3 minus 11 minus e squared minus 11 minus 11 squared. 3 times 2 is 9. 9 times 9 is 11 minus 99 minus 2 to the power 2 is 9. And minus 11 raised to the power 2 is minus 120. Minus 11 raised to the power 2 is 121. 121 times minus 1 gives us minus 121. And that will give us minus 99 times 9 plus 9 rather. Minus 99 minus 9. Minus 99 minus 9 minus 121 minus 229 minus 229. So that's our final answer to this. So we say therefore 2 star minus 1 star 2 equal to minus 229. Determine whether the binary operation is commutative on the following: A star B is equal to AB minus A plus B. Well, generally, since this is multiplication and this addition, that means A star B is commutative because B star A would give you the same result as A star B, because multiplication is commutative and addition is commutative. But let's simplify to see if that's true. So A star B is A, B, minus times A is minus E, minus times B equals minus B. That's the simpler it can get. Okay, so let's get B star E. So for B star E, the order is going to change here. So it will be B E, where for A B here it's going to be B A because we are starting with B and followed by E. So minus B plus E. So let's open our bracket. B E minus B minus E. Following the order of the letters alphabetically, E comes before P. So this will give us E minus B. So check, is it the same thing as this? So we say E star B, therefore B star E is equal to E star B. So this is our E because we have another part to work with. So say, since therefore B star E is equal to A star B, this implies that A, that's the operation star, is commutative. Next, so we get B. So this is 2 star 3, 2 star 3 star 4. So let's simplify this part. Let's call it N. Let N equal to 2 star 4. So let's evaluate N. 2 star 4. Following this rule, you can take this A B minus B, or this one, which is the same thing. So 2 star 4 is equal to EB. So E is 2 times 4. 3 times 4 minus E, which is 3 minus 4. So 12 minus 3 minus 4 is minus 7, and that's 5. So our N is 5. So therefore N is equal to 5. So let's rewrite this. 2 star 3 star 4 is equal to 2 star N, which is equal to 2 star, where N is equal to 5. So now let's evaluate 2 star 5. 2 star 5 is equal to, using the same rule of combination, E is 2 times 5 minus 2 minus 5. 2 times 5 is 10, minus 2 minus 7, minus 5 is minus 7, 10 minus 7 is 3. So we say therefore 2 star 3 star 4 is equal to 3. That's our answer. Which of the following binary operations is not commutative? So from the options A to D, we have to pick the option that has a binary operation which is not commutative. So for us to find out, we need to take each of them one after the other. So E, let's find out E. Option E says E star B is equal to A plus B minus 2AB one would be b star a. B star a will be b plus a minus 2ba. Alphabetically, it will be a plus b minus 2ab. So this means that a star b is equal to b star. So b star a is equal to a star b. So this implies that option E star is commutative. Star is commutative. Star is commutative. So option B, a star b is equal to 2a plus 2b minus 3b. So b star a 3b plus 2a minus ba. Alphabetically, 2a plus 2b minus ab minus equal to a star b. So b, therefore b star a is equal to a star b. So star is commutative. Star is commutative. Option C, a star b is equal to 2 over a plus 2 over b. B star a. We simplify a star b. LCM will be a. A divided by a is 2b plus a divided by b will give us 2a. So this will give us alphabetically 2a plus 2b over ab. So let's solve b star a will give us b star e equal to 2 over b plus 2 over a. So alphabetically, LCM is b a. This is also alphabetically is also equal to ab. A into b will give us 2a, 2a plus 2b. Okay, so what do you have? Which is also equal to a star b. So therefore, b star a is equal to a star b. So what do you notice? Or what's the conclusion? Star is commutative. That's commutative. So option D. Option B, a star b. A star b is equal to a minus b plus 2ab. A minus b plus 2ab. So b star a is equal to b minus a plus 2ba. Well, alphabetically, if you arrange it alphabetically, so that minus a plus b plus 2ab, where this part is the same because it's multiplication, and multiplication operation is commutative, so these two parts are commutative, but subtraction is not commutative. Why? Here is positive, but b a star b is positive and b star a is negative. In a star b is negative and b star a is positive. So you can see that a star b, or you can see b star a is not equal to a star b. So what does that mean? It means that star is not commutative. Star is not commutative. So here our option is D. Answer is D. Which of the following binary operations is commutative in the set of integers? So in this code number 2, we have to pick or find out the option that the binary operation is commutative. So which means the others are not, but only one is commutative. So let's find out. Option A is A plus 2ab. A plus 2ab. A plus 2ab. So b star a is equal to b plus 2 BE. So if you go by alphabetical arrangement of letters, alphabetical arrangement of letters, B, A comes first, so B plus B plus 2 B. Alright, so let's see. So A star B is not equal to, because in A star B we have A, in B star A we have B. So it's not equal to A plus 2AB. So we say B star A is not equal to A star B. So what do we see? Star is not commutative. Star is not commutative. So option B. A star, option B, A star B. A star B is equal to A plus B, A plus B minus AB. What would B star A give us? B star A. That will give us B plus A minus BA. Alphabetical arrangement of letters, A will come first, A plus B minus AB. And what do we have? Back to A star B. So what do we have to say? Therefore, B star A is equal to A star B. It implies that star is commutative. And this will be our answer. But let's still check C and D. So C, option C, A star B. A star B is equal to A squared plus B. And then B star A is equal to B plus E squared. B star A will be B squared rather. So in place of you have A squared will be B squared plus E. So what it implies that this B star A is not equal to A star B. So star is not commutative. Star is not commutative. What about D? D, A star B. A star B is equal to B plus 1 over 2. So when we open A times B is AB plus 3 over 2. That's what B star is. B star is equal to B A plus 1 over 2. So when we expand that, give us AB plus B over 2. So AB plus B over 2. So this will give us AB plus B is the same as AB plus E below. So B star A is not equal to A star B. So star is also not commutative. It's also not commutative. So our conclusion is, which of the following binary operations is commutative in the set of integers? Well, from what we have found out, A is not, C is not, and D is not. So B is commutative. B is the right option.